Okay, hopefully you guys all have a chance to try it. And I know some of you guys cannot wait, so I will tell you guys what the answer is. The answer to this is 1260. Yes, this right here is enough to have 36 factors, okay? And you can comment down below and share your approach with us, and I'm going to share mine with you right now. First of all, I will just go over with you guys. How are you going to find the number of factors? Let's say I will just call the number to be n. I want to find the number of factors that n has. Well, first step, we are going to prime factor the number n. And you're going to get a bunch of primes, right? So I'm just going to say p1 for the first prime. And maybe it has some exponents, so I'll just call the exponent to be alpha 1, okay? And sometimes you may have more primes. It's okay, you can just multiply by p2, and then it has maybe different exponents, so I will call the alpha 2, and so on, so on, so on, dot, dot, dot. And because n is finite, so the number of primes has to be finite as well. So let's put down Pn and alpha n right here. Actually, no, because I use n right here, so let me use m right here, okay? So Pm, it's like pi m, and alpha m, oh my God. It's like the YouTuber alpha m. If you guys know what I'm talking about, yeah, you can leave a comment down below too. Cool. Anyway, so just a quick example along the way. So let's look at the number 20. So if you look at the number 20, you can prime factor that, which is 2 times 2 times 5. It can collect the 2's, so it becomes 2 to the second power times 5 to the first power. And sometimes you may have, different primes, after that. It's okay. Anyway, if you want to find the number of primes that 20 has, this is all we have to do. The factors of 20, it has to be in the form of 2 to some power times 5 to some power. And you see, this is 2, right? The power right there, it can go from 0, 1, and 2. Because if you just ignore the 2, 5 is a factor of 20, right? So pay attention to the exponent. The first thing you do is you do 2 and you add 1, because this right here goes from 0 up to 1. And you multiply by, because now you have 0 and 1, right? So you do 1 plus 1. So you have 2 choices from the 5s and then 3 choices from the 2 to the power. And you multiply this, you will get 6. So the number 20 has 6 factors. So in other words, once you factorize n like this, I can tell you guys that this right here has, I will pay attention to the exponent, alpha 1, and then add 1 to it, because this right here, it goes from 0, 1, 2, 3, up to alpha 1. So we have this many choices to use this part to construct a factor for the n, right? And then similarly, we can do the next one, namely alpha 2. This is my 2, let me write it down better. Plus 1 times dot, dot, dot. Lastly, we have alpha m, and then plus 1, like this. So this is just like the formula, and we have this many factors, okay? And that's the idea that I demonstrated right here. And for the last video, it's pretty much just this, right? Well, today it's different because we are going to do it backwards. So it's much harder actually. We are going to find the number that has 36 factors. So I want the number of factors to be 36. And let's do a quick review. Last time, the way that we got 36, it was because 6 times 6, okay? So we can break down the 36 as 6 times 6. So this right here, remember, and in fact, this right here, they don't have to be primes. They do not have to be primes. Only the P1, P2, these numbers have to be primes. Anyway, last time, what we did was, well, when we have 6 right here, it tells us that we have P1 for the base, and then to the 5th power. You just do 6 minus 1, you get 5. And then you multiply by another prime, P2, and then to the 5th power as well. And to get 100,000, P1 was 2 and P2 was 5, right? Okay, so you might think that, okay, because I use 2 to the 5th times 5 to the 5th, that's why we get 100,000, and that's why it's too big. Maybe we can just choose a different prime. So instead of 5, we can maybe use 3. Sure, that will give you guys another number that's going to give us 36 factors as well. But this number is not going to be the smallest neither. Okay, so unfortunately that's not the case. Now we have to just come back here to see how we can break down 36. And the truth is, it doesn't have to be 6 times 6. I can have more for this because we might have more alphas like that. So let's take a look at another way. Maybe I'm going to do 2 times 3, which is 6, and I'm going to keep this 6, all right? So when we have 2 times 3 times 6, this is going to associate to the following form. The number n has to be in the form of p1 to the first power, because 2 minus 1 is 1, times p2, 3 minus 1 is 2, to the second power, times p3 to the fifth power, right? So if you want to look at 36 as 2 times 3 times 6, that means your number n has to be in this form. And now we just have to choose our primes, right? Notice that this right here has the biggest exponent, so I shall put the smallest prime right here for P3, namely 2, right? 2 is the smallest prime. Don't use 1, of course. 1 is not prime. And then right here, okay, the next prime, because I have the exponent 2 right here, so I will just pick 3 like that. And then the next smallest prime, which is 5 to the first power like this. Okay, if you multiply this out, 5 to the first times 3 to the second times 2 to the fifth, if you multiply this out, you will end up with 1,440, okay? So that's, oh wow, it's much smaller than the 100,000, right? But this is actually not the answer, okay? Suppose you didn't know about that. So the deal is that you just have to make sure, maybe you can find another smaller way to construct your n. So let's come here and break down 36 again. Maybe we can do 4 times 9, which is 36. But if you're talking about 4 and 9, that means you're talking about something to the third power and something to the eighth power. So I don't think that will give us anything smaller than that. You can try and let me know. I don't know. All right. So instead of that, let's do 3 times 3, which is 9, and times 4, yeah? 3 times 3 times 4. So it's a pretty good balance, and it's just like a review, that kind of, So if you want to get to 36 with 3 times 3 times 4, this means that the number n is in the form of p1 to the second power times p2 to the second power times p3 to the third power. Okay, this has the biggest exponent, so I should assign p3 to be the smallest prime, which is once again 2. This right here, the exponents are just 2, so I can just put 3 right here and then put 5 right here. And of course, I don't want to use 7, I don't want to use 11 because the number will be much bigger compared to if you use just these small primes, right? But anyway, if you multiply this out, 5 to the second times 3 to the second times 2 to the third, in this case, you will end up with 1800, okay? Yeah. Okay, so now let's see. Let's try to break this down again. Well, 2 times 2 is 4, so maybe I can look at this as 2 times 2 times 3 times 3, right? Once again, these right here, they don't have to be primes, but yeah, I just end up with primes right here, okay? And I have 4 numbers here, so that means I should have 4 primes over there. This right here is telling us that the number n is in the following form. P1 to the first power times P2 to the first power, and then P3 to the second, P4 to the second, right? So let me just put this down for you guys. So in this case, I have to just get 4 prime numbers. And similar to what we have done earlier, this right here has a big exponent, right, compared to the other ones. So I will assign the small prime right here, which is 2. And then I will assign this right here to be 3. I will assign this to be 5. I have to use another prime. So the next smallest prime, which is 7. And if you multiply this out, 7 to the first times 5 to the first times 2 to the second times 3 to the second, 2 to the second, like this, okay? In the end, you end up with 1, 2, 6, 0, okay? This right here, it's a smallest positive whole number that will give you 36 factors.